guys, welcome back to In Case of Econ Struggles. Today I'm going to keep talking about dynamic optimization. In particular, I'm going to show how you can solve some of these problems in Excel using Solver. So first what we're going to do is we're going to set up the math, then we're going to jump into Excel, and I'm going to show you how to set up and use Solver. Then we're going to use this example to show how Solver works. So as usual, timestamps are below if you would like to jump around. Let's go ahead and get right into it. So here's the example problem that I came up with. A lot of times you're going to be talking about something like fishery or forestry. This is just something a little different. Now we've got Bill. Bill's an elk farmer. Bill's going to sell some amount of wool in period T for price P. And basically you can think of WT as the number of elk that Bill is going to shear in a particular period. Can you shear elk to make wool? I have no idea. I just came up with it because it's kind of fun. And so what we're going to say is that he's got a number of elk that he's able to shear in the herd. It's going to be HT, and what's happening is that Bill has got these elk on some sort of field, and that field can only handle a certain amount of herd size, and we're going to call that maximum herd size the carrying capacity, or K. And basically what we're going to have is in each period, Bill's going to have an additional number of elk that are ready to be sheared, and some elk are going to retire. They're going to go into a separate pasture. They can't be sheared anymore. They're just going to hang out for the rest of their lives and vibe. And we're going to say that this shearing is costly to Bill. We're going to say that the cost is just going to be some number C times the amount of elk that Bill wants to shear squared. Okay, so this is just the setup. And first we need to start thinking about the math. We just add some equations now. If I think about Bill's profit, which is what he wants to maximize, his profit is just going to be the price times WT minus the cost times WT squared, where again WT is the number of elk that he's going to shear in a given period. We're going to say that we've got some net growth function in terms of how many elk Bill can shear in the next period. That's going to be some number R, some scalar R, times HT, or the number of elk in the herd, times 1 minus HT over K, where again, HT, we're in the herd and we're able to be sheared. If we can't be sheared anymore, we don't count. We go into a separate pasture where we get to vibe. And so if we use these equations, we can figure out how many elk are in the herd and able to be sheared in the next period. It's just how many elk we had in this period, minus how many elk we choose to shear, plus this net growth function. And so the question here is, suppose that Bill wants to farm for 10 years, where each year is a period, and he's going to start out with a full herd. He's going to start out with H0 being equal to 1. And if the discount rate is 3%, what is the optimal number of elk that Bill wants to shear in each period between 0 and period 9? So if we just set up this Lagrangian, I'm going to use beta instead of rho, and the reason I'm going to use beta instead of rho is because I've got a P in here, and it's really hard for me to differentiate between P's and rho's, so I'm going to use beta, but it means the same thing as rho, where I'm just going to say beta is 1 over 1 plus delta. And so what I'm going to do is I'm going to set this up where I have beta t times price WT, where this is just my profit function here, plus beta times lambda t, and then times my basically equation that determines how many elk I have in the next period, which is just HT minus WT plus net growth minus HT plus 1, where if I break this equation up into sort of state variables, choice variables, and parameters, my state variable in each period is just how many elk I wake up with and are able to be sheared. My choice variable in each period between 0 and 9 is just how many elk I want to shear in that day. Some parameters, I've got my discount rate, I've got this R, I've got this K, which is just given, the number of elk in my herd that I'm going to start with, and the number of elk that I'm going to start with in my field. I'm actually going to change that and make that 0.5 because my carrying capacity is 1. So it's just going to get a little weird if when I start out, I have basically a full field and I can't have any more elk that are going to be supported by this field. So I'm just going to change it and say that when I start, I'm going to have 50% of my maximum elk in this field, where again, this is not like half an elk. This is just saying 50% of the carrying capacity, and that way sort of my interpretation is going to be percentage of my full field, or of my max carrying capacity rather than number of elk. And now I'm just going to do the math. I'm going to take the first order conditions. I'm going to omit the partial of the Lagrangian with respect to beta times lambda, because that's just going to give me my constraint back, and I already have that. So notice you will need to take that. That is a first order condition you need. I'm just omitting it for space and for time. And so I'm going to dive in and take the derivative of the Lagrangian with respect to WT, which is just going to be this guy right here. I'm going to set it equal to 0 so it becomes a first order condition. And when I sort of rearrange this equation, I'm going to see that my marginal benefit, if I shear one more elk, then I'm going to get some extra profit. That's going to be what my extra profit is, but I'm not going to be able to shear that elk in a future period. And so that's going to be my opportunity cost, which is going to be on my right-hand side. And if I were to divide this by beta, I could figure out exactly what lambda t is. Now I'm going to take the first order condition with respect to ht, which just means I'm going to figure out what happens to my Lagrangian if I had an extra elk in the herd. And so that's going to be this messy equation here. Remember that for ht, and I've talked about this before with the state variable, you're going to have two parts. ht appears in my Lagrangian both today and it appeared yesterday, because if I think of yesterday, this ht plus 1 becomes an ht. And so my first order condition for my state variable needs to have two parts. So those are my two parts right here. If I do a little bit of algebra and I rearrange it a little bit, what I'm going to get to is I'm going to get that basically the number of extra elk that I'm going to have tomorrow if I leave one additional elk in the herd. If I don't shear that elk, that's just going to be equal to 1 over beta times the ratios of my opportunity cost. What I'm saying is this is my opportunity cost of that elk today. This is my opportunity cost of that elk tomorrow. And it's going to be discounted. And by discounted, I mean it's in the future, because this is tomorrow. This is the number of extra elk I have tomorrow. And so this needs to be tomorrow over today. And I'm going to take the value into tomorrow dollars. So now we have everything we need, and we're just going to go into Excel, and in Excel, we're going to start to use Solver. Okay, so now I'm in Excel, and basically what I've done is I've set up this spreadsheet. This is my example problem, where I've sort of got my delta, my beta, and all those parameters that I said before. And then these are my formulas, roughly. I've just sort of typed them out by hand just so I can remember them without having to reference my iPad. And so again, we're going to use Solver. So the first thing I'm going to do is tell you how to get Solver. Most of the time, most of you, it'll be under the Insert tab. You could be able to see Insert add-ins. For me, it's under Developer, which is just because I have this in. So basically what you're going to do is you're going to find Insert add-ins or Developer add-ins. And then you're just going to go into Store and you're just going to search for Solver. And if you search for Solver, it'll pop up. You can add and then just hit Accept the Terms and it'll pop it. Okay. So that's how you get Solver. For me, it appears over here. For some of you, it might appear like over here in Home. Okay, so now what I've got is I want to set up my spreadsheet or my initial guess for how this is going to go. So I'm going to type in initial guess, and I don't know, I'll make that a fun color just so I can remember it. I'll make that bold, again, just for fun. And so sort of the things I need in my spreadsheet, I need time. I need to know what H is. I need to know what F of H is, or my growth. And I'll make that lowercase, F of H. I want to know W. I need to know profit, which I'm going to call pi. And I need to know the present value of pi. Okay, so now I've got this set up. And now I need to go from period 0 to 9 because I have 10 periods. Once I type in 0 to 1, I've got some options. I can either wait until this cursor becomes a plus and then pull it down. And then it's going to say 9. Okay, so now for H, I know that my H0 is 0.5, so let me plug that in. Now my F of H, this is going to be equal to R times H, which is right here. And then I need a multiplication, so times, and then 1 minus, so 1 minus, then H over K. It'll do H over K without any parentheses, but I like to have them. So H minus K like that, and then it's going to tell me that I need a parentheses, going to put them in. For an initial guess, I don't know, let's just say we harvest 10% of the herd in every period. My pi, this is just going to be equal to price times the amount that I harvest, minus the cost times the amount of elk, which is that guy, quantity squared. And then PV of pi is equal to beta to the t times pi. Okay, so now I've got sort of my first row. One thing to note though is if I were to just drag one of these down, like this F of H guy, if I were to drag this down, you're going to see that what's happening is now it's referencing H0 and K, whereas before it was referencing R and K. That's because this is not locked yet. So if I want to lock, if I want to tell Excel, hey, when I tell you B6, always look at B6, I need to use F4, or I need to put in these dollar signs for each of these guys. So let me just zoom in so you make it a little clearer. I need to have these dollar signs basically on any cell that I want to lock. So like B7 I want to lock. I can go over here, this is a guess. but like this price and this cost I want to lock, and also this beta, this B3 I also want to lock. Okay, so now we're getting there. Now the only thing I need to know is I need to know what H is in the next period, but I know H in the next period is just whatever H was last period, plus whatever the growth was, minus whatever I took out. So that's what H is right there. And you can see it's going to be 0.65. And then, of course, I didn't lock this, so it's giving me a nonsensical answer. So I'll drag this back down, and that gives me a much more reasonable answer. 0.1, I'm going to keep that the same. That's just my initial guess. And so now if I drag this guy down, I can either hold and drag all the way to 9, or if I want, I can just double click in this bottom right-hand box. And then I can go like this. I'll just double check to make sure this is locked, and it is. So I'll put that down. I'll double check that this is locked, and it is, and I'll pull this down. Okay, so now all I need to do is I need to do a sum. Maybe I'll put a line here just for fun. And this sum, I want to maximize my present value of profits. So it looks like that. And now I have my initial guess. Next, what I'm going to do is I'm going to pop over here. I'm going to copy everything. And this is going to be what I put in the solver. The reason I'm doing that is, of course, because if I mess something up in here, I want to make sure that I still have a nice initial guess that I can just copy and paste over, and everything will be dandy. So now what I'm going to do is I'm going to open solver. Again, some of you might be over here in the top ribbon. For me, it's in this own separate category, this own separate tab, and I'm just going to pop it open. All right, my objective, what am I trying to maximize? Well, I want to maximize this sum right here. For variables, I get to choose W in every period, and I can choose them to be different in every period. So those are going to be my variables. Constraints, it shouldn't matter, but sometimes Excel gets a little happy and thinks that it can choose whatever number you want. I don't want this W to be like a 10 because I know that my herd size is only like, I don't know, 0.65 or something. So what I'm going to say is I'm going to say that my left hand or my K's or my W's, they've got to be less than or equal to my H's in every period. And Excel will know to line that up and say this W has to be less than this, then this, and just all the way through. So I'll hit OK, and then I'll hit play. And when I hit play, what I'm going to get is it's basically going to change all of these W's to the maximum value, and it's going to take a second. Okay, and now solver's found the solution. You could say it's converged to the current solution, where we've now got a PV5 of 2.06. But what this tells you is that if the carrying capacity is 1, and you start with 50% of the carrying capacity being taken up by elk, this is the proportion of the carrying capacity that you should harvest in every period T, if you're only harvesting 0 to 9. So you're only working for 10 periods. Now there's other ways to make this problem more complicated, and we'll cover those as they come up. But again, hopefully this is just a really quick reference video on solver and some of the math. So if this was helpful, please like and subscribe. We'll see you next time for another case of econ struggles.